All right, welcome everyone. So we have a bunch of people who are tuning in remotely for this webinar. Welcome to the next installation of the next episode of our Getting Started webinar series. Today we are going to be covering getting started with Mapbox Geocoding. So I am Chris Wong, Senior Developer Evangelist here at Mapbox, and today I'm joined by Robert and Mark, Product Manager and Software Engineer respectively from our search team. They'll be doing the presenting today. I will be moderating or hosting, if you will. So I'll keep an eye on the chat, and I will definitely be relaying messages or stopping if there's anything you have question-wise. So yeah, drop your messages in the chat, and I will find a good time to ask them. You should definitely, if you're not familiar with Mapbox, this is one where we're going to be spending more time on sort of the background infrastructure, like search that powers maps, but not the maps them. We won't be focusing on the maps themselves, but what you can do with search results. But we also have navigation products, and we also have rich data products. So go check out mapbox.com and see our full suite of product offerings. It's a full location services platform. I also want to give a plug for our Discord server. So we have a vibrant Discord server, has almost 3,000 members in it at this point. And it's a great place to go get help and see if you can connect with the community on whatever you're building, share what you're working on. We do events and things like that in it as well. But go ahead and check that out. It might be a great place to follow up if you want to try using the geocoders. And then today, basically, quick rundown what we're going to cover before I turn it over to Mark. Or to Robert. So we're going to access and configure the Geocoding API. We're going to do some forward and reverse geocoding. We're going to add a geocoder to a web map, and we're going to implement address autofill, which is just a geocoder plus some follow-up tasks to actually fill out a form with an address, with all the address parts. So without further ado, I'll turn it over to Robert Florence, and you can take it away. And let's get started in learning about geocoding.
Thank you, Chris, and thank you everyone for joining me today. My name is Robert Florence. I'm the product manager for Geocoding, based out of Salt Lake City, and I've been at Mapbox for about 6 months. So I think Chris did a great job of covering kind of there's the map search navigation split. I'm going to go into presentation mode real quick. Everyone can see my screen okay?
It looks great.
Great. So geocoding is part of our search vertical. Geocoding is really about finding addresses and places, things like 2595 Lucky John Drive or Park City, Utah, or Paris, France, places like that, and addresses. There's also a search product that has points of interest where you could search coffee or McDonald's or things like that. That's not part of geocoding. Geocoding's the part of search that's really focused on addresses. And so the first thing I kind of want to talk about is what is really sitting behind geocoding. How do we geocode? How do we assemble all this data? So we have over 2,000 different address data sets it's probably over 400 million records at this point. And we have open source data sources like OpenStreetMap, Open Addresses, and then we partner with lots of private vendors and license their data sets as well. So on top of that, we've kind of got all these different data sets that we bring together. We enrich this with telemetry, aerial imagery, building footprints, parcels, things like that. And this is something that we're constantly adding new data sets to keep up with new construction and more new geographies across the world. And basically, because we have all these different data sources at Mapbox, all these kind of proprietary data sources, what happens is we end up having multiple addresses. We have duplicates of any given address. And so we're in the position where kind of our secret sauce is, how do we pick the most accurate address? Different providers might think that an address is in a different place, And so what we'll do is we'll load all this data in our pipeline. We'll kind of compare different points with each other. We'll then look at the road network, the named road network, to see which appear to match up with the road network the best. We'll then look at our parcel data set. We have these data sets that describe the polygons of ownership of different pieces of land. And we'll use that plus the building polygons. We'll look at the rooftop of the building and determine, hey, does this point actually land on top of a building? And then we'll pick that one canonical best location for that address. And then the last thing I just want to talk about before we get into it is all of this is backed by a really robust corrections pipeline. We've got hundreds of people on a team that manually reviews corrections that are submitted by end users and our clients to mapbox.com/contribute. And they'll go look at, oh, someone said there's a new address here, or someone said this address is in a slightly different location. And that team goes and looks at satellite imagery. They look at street view data. They look at ground truth sources to make those updates. So we make hundreds of thousands of updates to our maps every month. So to get into it, there's two types, like very high level, there's two types of geocoding. There's forward geocoding and reverse geocoding. How you can think about forward geocoding is you've got an address string or the name of a place or a zip code or something like that. And you want to find out what is the latitude and longitude of that. And so you'd submit a forward geocoding request. We would go find that address or place, and then we would return the location back to you. So this is great for if someone needs to register a shipping address or a home address in e-commerce. If you need to deliver packages or food to someone's address, or if someone needs to find a shop or service that's near them, or also in business intelligence use cases, forward geocoding is very useful. Reverse geocoding is just the opposite. It's you give us a location coordinate, you give us a latitude and longitude, and we'll go find an address. Or optionally, we can find different features that map to that coordinate, such as, again, a city name or a postcode. And this is often used in things like content tagging. Lots of photos have metadata on them that have a latitude and longitude. And maybe you want to enable your end users to kind of group those photos by where they were taken, for example. So that's a great use for reverse geocoding. Another one is asset tracking. There's companies that want to take where their delivery trucks have been and be able to record that for regulatory purposes. Another one is nearby search. You can grab the latitude and longitude from another geolocation service. We don't offer geolocation directly, but you can pass us a coordinate and then know where that user is and search for things around them. Beyond that, one thing that's unique about Mapbox is we offer two types of geocoding, and these apply to both forward and reverse. Most companies just offer temporary geocoding, and what that means is that you can geocode an address with us and display it to your user or filter a list of results, but then you need to essentially throw that data away. You can't store that geocode in your database. But Mapbox offers another SKU called permanent geocoding. The data behind these is totally the same, only the endpoint and licensing is different. But when you use permanent geocoding, you're allowed to keep that data indefinitely. So if you need to save users' home addresses, register locations of work sites, report on things, permanent geocoding is the right product to use. And we deliver geocoding through a number of different ways. These are three of them. So there's the Geocoding API, of course, and we'll be experimenting with that in like 2 minutes. There's Geocoder, which is kind of a wrapper around that Geocoding API that makes it really easy to put address search box into a map. And then there's address autofill, which is a really kind of complete experience for building something like a checkout page where you capture addresses. And it helps not only geocode and find addresses, but it also does the work of filling in an address form, putting all the components in the right place, and also displaying a map to the user so that the user can confirm where their address actually is. Last thing that I want to mention is I think there's a misconception that geocoding is just about addresses. But actually our geocoder, when you geocode an address, we return a whole geographical context hierarchy. So we'll tell you what neighborhood that address is, what postcode the address is in, localities. These are things like boroughs in New York. I'll tell you the city it's in. Districts in the US are usually counties. And then region is usually a state and then a country. And these are actually all geographic feature types here that you can search for directly. Not only will we tell you the geographical hierarchy, but you don't need to search for an address. You can search for a neighborhood or a postcode or a region. And there's lots of reasons to do that. For example, lots of people search for services by zip code, for example, like healthcare services. So that's the use case there.
Hey, real quick, Robert, we had a question in the chat, and it was about temporary versus permanent geocoding. And the question is, can POIs be stored now with permanent geocoding? I don't know if that used to be a restriction, but maybe you can share anything about that.
I believe they can in our current, in the currently available geocoding solution, but let me take that as homework that we can follow up on.
Sure. And for those who don't know, POI means point of interest, in case you missed that, but it basically means the things that are like coffee shops or restaurants or attractions or things like that, not specifically addresses.
That's right.
Okay, thanks.
Cool. All right, so let's jump into the playground. So I'm gonna actually I might just give a link to this in the chat real quick, in case you want to mess with it while I am as well. So this is our geocoding playground. This is where you can make forward and reverse searches. And what we're going to do a little bit here is kind of explore what the geocoding request and response look like and what parameters we can mess with to get better results. So the first thing, let's do a forward geocoding request. So let's search for a Lucky John Drive. Okay, so this is a GET request. You send the query right in the URL path, followed by .json. And you'll notice in the response object that what's returned is actually a list of features. And we will order these in the most relevant order. The first feature will be what we think is the best answer for the query that you've given here. And I want to go through a couple things about this response object. So you'll see that you'll get an ID back. This can be used to retrieve that feature in the future. This type is a GeoJSON kind of standard. It's not very important. This place type is actually more important. So what we've returned here is an address, as opposed to, for example, a postcode or a city. And then you'll be able to check the relevance score. This has to do with the order that we return results in. This tells you how relevant we think this particular geographic feature is to the query that you've submitted to us. Then what we'll do is we'll break out the accuracy here. There's different accuracy levels that you can check in our documentation. Rooftop is sort of the best level of accuracy that you can get back from the geocoder, and it means that the address result, the coordinate result we've found for you, actually we've confirmed that it lies right on top of the rooftop of a building for that address. Here, when you want to get the actual latitude and longitude, they're here. You do have to keep in mind that the result, the API response actually returns it in the form of longitude latitude, which is a little bit of a gotcha if you didn't know it before. Geometry is basically a copy of this. This is kind of a GeoJSON format kind of legacy piece that you don't need to pay attention to. And then importantly, there's the context object. And this is where you'll be able to get the full geographic hierarchy of this feature. So you can see here, this is the neighborhood it's in. You can go actually query for this neighborhood directly using this ID, for example. This is the postcode it's in. This is the city it's in. Place is what we use for a city. This is the county it's in. This is the state it's in. This is the country it's in. And so whenever you query for an address, you're going to get back that full geographical context hierarchy. It's going to be really useful for grouping data on your side. So speaking of these different context layers, not only are they returned to you, you can actually search for these directly. So let's say you want to enable your users to just search for their postcode. What you can do here is, let's remove this. You can set a filter called types. And so by default, we'll return any of those types: neighborhoods, countries, regions, postcodes, addresses. But if, let's say, you only want postcodes back, you can select postcode here. And when you type in a postcode, you'll see this list of features, see that its ID is also of a postcode. And so the place type is postcode. So that's the way to use the types filter to specify what types of geographical feature that you want to get back. Let's look at a couple more parameters. A really important one is the IP proximity parameter. So when a user starts typing something into the Geocoding API, there's lots of places in the world that have the same name, for example. There's a Paris in Texas in the US. And so one of the things we consider is the prominence of different features, like the popularity. But another thing we consider is the distance to any given feature from where the user is. And the way you can enable that is by setting IP proximity. So if I have IP proximity on, I'm right now in Salt Lake City, Utah. So when I type in Paris, you can see that there's a Paris, Idaho here. So Utah is a state very close to Idaho. It's the neighboring state. Texas is a little farther away. So you can see with IP proximity on, it's actually, first it's finding a POI in Salt Lake City because that's where I am. Then it's finding a city in Idaho because it's very close to me. Then it's placing third Paris, France, because even though Paris, France is farther away from Paris, Texas, the prominence of Paris in France is much higher in general. So it gets bumped up in this list. So if we turn off this IP proximity and we type in Paris, now the API doesn't know where this query is coming from. And so it's just going to use that prominent score. And so it's going to pop up Paris, France as the first result because Paris, France is the most prominent geographical location that contains that string. Let's do a couple other experiments with the parameters here. One is you can set a language. This is something you could potentially detect from the browser or OS, but entering a language will essentially allow you to type in. So let's set the language to Spanish. It'll allow you to get better results for typing names in that language. So we have a New York in Spanish. And then on top of that, in the response object, you'll actually get back the translations for that language. So if you need to get multiple translations, you can actually define multiple languages here. Let's look at a couple others. So it's 1049. Let's look at a couple others. One is autocomplete. So autocomplete is on by default, but if it's not on, basically we will treat any string that you give us as complete. So if autocomplete is off, when you type India, it's going to treat India as the complete string. And you can see it's returning India as this first result here. Now, if autocomplete is on, you'll actually see you'll see results like Indian Village, which is a POI in Utah, because it actually completed that result for you. Another one to cover really quickly is fuzzy matching. Fuzzy matching is actually slightly different than autocomplete. Fuzzy matching is also on by default, but if you don't want it on, it will, so let's misspell Indiana. So you can see in this case, we don't find it, but if we turn fuzzy matching on, we'll find Indiana in the United States. So those are some kind of query parameters that you can mess with to get better results for your users. Another great one to use is country. If you ever want to only get results from a specific country, I recommend setting that country filter. I'm going to jump over to doing a demo of how to add this box here to a Mapbox map. But before then, Chris, Are there any questions that I should get to?
Actually, one just popped out right now. So it says your coverage page mentions premium, basic, or low coverage per country. What does that mean?
So those numbers will, those ratings will have to do with the ratio of address coverage we have to the population of those countries. So generally speaking, I can't remember what the exact ratings are, but in our highest rating, you can expect, well above 95% coverage. And it kind of goes down from there. It's something that we're constantly improving. We're really strong in the US, Canada, Western Europe, and Japan. And then we're constantly improving in other locations.
Awesome. Yeah, no other questions right now. So if you want to move
Okay,
on to the
cool.
demo, that's great.
Let's do that. Am I sharing my whole desktop? Can you see Visual
Yes,
Studio right now?
Yeah.
Great.
Looks
Okay.
great.
So what I've got here is just a little HTML file, and this is a tutorial actually right here, which I'll share later in the chat. And what you're seeing here is we've got some links to Mapbox GLJS to import that. I've got a throwaway token here for this webinar that we defined here in the script. And you can see there's a map instantiated here, a Mapbox GLJS map. And so if we open this, you'll see this is just your kind of standard Mapbox map. And you can kind of scroll around, things will pop up on the map. But it's not really deeply interactive in any way. And so one thing you might want to do is enable someone to search an address. So in that situation, what you're going to do is come here, and you're going to need to import a couple of scripts for the geocoder. Do that. So we've got the main script here for the geocoder. We've got a style sheet for the geocoder. And then the next thing we're going to want to do is add a map control. And so what that looks like is down here below where we have instantiated the map, we're going to do map.add control and instantiate a new Mapbox geocoder. It's going to use the same access token that we're using for this map. And now when we save this and refresh the page, you're going to see this box pop up in the top right here. We're going to be able to search for an address, select one, and it'll pop you over to where that address is with a pin right on top of it. And this GL geocoder can be configured in all the ways that we've kind of talked about already. And I'll share a page later where you can see the different parameters that are available to configure this. But let's just do one really quick right now, which is how to enable reverse geocoding. So let's first, so what we'll do is come back here, and as we instantiate it, we're going to add another parameter here that I think it's reverse geocode. Yep, reverse geocode. Set that to true. And then now what we'll be able to do is when we come back to this demo and refresh the page, we'll actually be able to submit latitude and longitude here. So you can see this latitude and longitude corresponds exactly actually to the forward result that we just searched. And just one gotcha here is that if you do it how I'm doing it, the input for reverse geocoding is in the form of latitude, longitude here. Whereas oftentimes in our API response, you might see longitude come before latitude. So that's just something to be aware of. That's about it for this demo and the playground demo. The next thing we're going to jump to is Mark is one of the developers on the team. He's going to show how to use address autofill. But before then, are there any questions I should answer?
So yeah, I'm not seeing any in the chat, but if anyone has a question they want to type quickly before we move on to the next demonstration. Okay, I do see. Yeah, so the question that just popped up was, I had noticed that longitude comes before latitude. I'm curious why that is. I'll just chime in with I think this is a debate as old as mapping, or maybe as old as digital mapping, but long lat or longitude latitude is XY, and a lot of people like to do things in that order because it's more logical from a mathematical standpoint. But I think yeah, maybe you'll agree or disagree, Robert, but I think the reason that the UI is doing it in lat long is that that's how more of the end users of maps would think about it. Would you agree?
That's essentially the answer. Yeah, thank you.
Yeah. Okay. Doesn't look like we have other questions. So with that, we'll move on and we'll hand it over to Mark, right?
Awesome. Thanks, everyone. Let me share my screen real quick. Cool. Let me know. Does that come through to everyone?
Looking good.
Looks great.
Awesome. So thanks everyone for joining the webinar. My name is Mark Potier. I'm a software engineer here with Mapbox, based out of Portland, Oregon. I'm going to be showing you how you can use an address autofill component inside a checkout form. Specifically, I'll be showing it in a React example, but we do have vanilla web components that you could use for a non-React application as well. And just to show you kind of what we're going to be aiming for today, if you look at a checkout form like this, we're talking about starting to type in an address here and getting a list of suggestions from Mapbox, which when a user chooses one, it automatically propagates those address components into their respective fields within the form. There's a couple other bells and whistles that we have with our SDK that include a kind of confirmation map, as well as a confirmation modal if you choose to use it. So that's what we'll be working towards. And one other plug before I get started, I do recommend checking out our Mapbox search JS documentation site, which has all of the information that I'll be covering today, plus a lot of additional things that I won't be showing. But in terms of installation and how to use it, this will have all the information that you need. So I definitely recommend checking that out. So with that said, let's get started coding. So I'm starting here with just sort of a basic React application. It's just a simple form. There's no special functionality happening. It's really just a series of input fields inside of a form. So the first thing that we want to do is import our search.js React library. And the way that we can do that is by doing an npm install, and we're using @mapbox/search.js React. And as I mentioned, we do have a search.js web library if you are not using React. Okay, so now within our package.json, we see that we've successfully imported this package. So the first thing that we're going to do, and I'll do a little bit of copying and pasting just to move things along, but the first thing we're going to do is go ahead and import our address autofill component into our React module. So address autofill. Now it's really simple how this works. Basically, what we want to do is wrap the input element that corresponds to the input that we want to be kind of imbuing this functionality into. And so I'm going to find that same input element, which is this one here. And I'm basically just going to create this address autofill React component and move our input inside of it. So it's now a child of address autofill. Now, the other thing that we'll need to do before we get started is pass in an access token as a prop. So I'm just going to define a constant at the top of my file using an access token that I created just for this demo here. Let's just call this access token. Cool. So now we'll pass this into our access token. So let me go ahead and start the server here. And let's see if we can get this working. All right. So now when I start typing into our address line, you can see we're starting to get some results back. Now, if I click on one of these, you'll notice that it's not actually filling out these address components yet. There's one other step that we need to take note of before we can get that to work. And primarily, that is that we need to, make sure that our input elements are children of a form element, which in this case, we already have that set up. But the other important thing is we need to make sure that each of these inputs that we want it to autofill into has an autocomplete tag. And an autocomplete tag is just a cue for the browser, but also for our SDK to understand what address component is this input targeting. So in this case, the name of this autocomplete tag is address line 1. And really quickly, I'll jump over to a resource that we do have within that search.js documentation site that I mentioned that lists out the specific autocomplete tags that apply to each address component. So this is just a handy little guide if you need it, but generally we're following standard browser specifications for autocomplete. So you may already have this in your application if you're following those same standards. But continuing on, so in order to complete adding these tags, I'll add one for the apartment line as well, which is called address line 2. I'll add one for city, which is actually called address level 2. The region tag is called address level 1. And postcode is called postal code. And that should be good. So I'm going to hit save and come back to our application. And so now if I select an address, you can see these address components are getting automatically filled into those components. So that part looks good. The next thing that I wanted to show is how can we get that kind of confirmation or helper map show up along with this. So this is just another component that we have within our library, and it's called address minimap. And let me grab another little block of code here, and then I'll talk about what it means and how it's working. So I'm going to drop this minimap after our last input element. And let me format this. So I'll come back to some of these features in a second, but basically the minimap requires 3 pieces of information that you pass to it. You need an access token, similar to the autofill component. You need to pass it a feature, which is going to be a GeoJSON feature that includes the coordinate information of where to center the map. And then show is just controls the visibility of the minimap. You can just set that to true for now. The feature itself will define when the minimap is visible. So what is this feature and how do we get it and how do we pass it into the minimap? Well, so for this React application, I'm actually just going to define this in a React state. So at the top of my React function, I'll just kind of set up some boilerplate to define this feature. And then so what we need to do next is figure out when can we set that feature. And what we can do is we can tap into a callback on the autofill component, which lets us intercept the response that we get back from it. So the prop that you're looking for here is called onRetrieve. And inside onRetrieve, you can pass a function which will get called whenever a user selects one of the suggestions that they get. And so what I'll do now is just define a small function called handleRetrieve. And then up here, I'll define handleRetrieve. And so all this is doing is when this function gets called, it's going to take as an argument the response that we're passing in from the autofill selection event. And we're just going to take the first feature that comes off of that. And then we're going to set that feature into our local React state. And so now this feature is just going to be passed in to our address mini map. So I'll save this. We'll come back to our application. And now when I select an address here, not only are we getting our address autofill components filled, but we're now getting a small map that shows the geographic location of this address. A couple of helpful things that you can customize with this. One of them is called satellite toggle. I'll set that to true. And this basically gives you the ability to switch back and forth between a satellite map and streets or other style map that you specify. So that could be helpful to kind of more easily help understand where you are. Another one is called
let me just real quick. So when a user does correct their address using this little mini map, that correction goes to that team that I've talked about, our corrections team, and they will see this kind of update to that location, and they will double check it against multiple ground truth sources, and then we'll ship that to our core data set to update the location of that address, which is usually reflected within 72 hours. So especially if you're delivering packages to users, you've got repeat users for a product or service, this is a really great solution. I mean, there's countless examples of people who always get their packages delivered to like the slightly wrong location. And so this can be really helpful.
Yeah, and so what Robert's referring to is if you enable a feature called can adjust marker, what that'll do is create a little button here that actually lets you move the map and more importantly, move the pin on the map. And so if as a customer, you say, oh, actually the pin should be, slightly over here for this given address, I can move it and then click save. And as Robert mentioned, that feedback will get sent to Mapbox. Now it's probably also important for the developer to capture that information so that if they want to send like a static image map on a receipt, or maybe they need to pass that updated coordinate to a courier, they can do that by passing in or by creating a callback that intercepts that coordinate. So we have a prop for that called on save marker location. And again, in this case, I'll just inline code this function and I'll just console it to, or log it to the console. So we can kind of see what that looks like. I'll also set a footer to an empty string just so I can kind of get rid of some of this margin right now. But so now if I were to select an address, and let me open up the console here in a second. So now if I adjust this pin and hit save, you can see we're capturing the coordinate that corresponds to this new pin location. So that might be helpful from a developer's perspective.
Mark, did that footer prop, is that literally just for writing like text or adding an element underneath the map?
Yeah, exactly. It's basically to give an instruction if you choose to pass one along to your end users for what to do with this.
Cool.
And there's a number of props and options with this mini map and with autofill that I'm not covering today, but if you look through our documentation, there's a lot of other really cool things you can do with these. You can customize the theme and style to match your branding. So anything that you see here today, there's a lot of customizability that is worth looking into. So things like the language of this button or the footer are all configurable.
I wanted to ask a really quick question. Well, my first question was whether this was an interactive Mapbox GL.js map or if it was from the static images API, which you answered by interacting with it and dragging it around. So if it's a real map, does this incur a map load just like any other normal Mapbox GL.js instance?
So this is actually, it is a static image map. We've done like a little trick to make it seem a little bit more interactive, but specifically for the purpose of kind of improving performance and functionality, we've basically created a static image map that's kind of overflows the bounds of this container. And so you can move around to an extent, but it's not going to be as endlessly interactive as a GL.js map. So it does incur a static image usage. However, with our address autofill product, because we use a session-based pricing, the call to address autofill for the address search plus the usage of the minimap and confirmation steps are all bundled within the same session.
Excellent. Thank you so much.
If we have a couple more minutes, there's just one other thing that I was going to show, which is that confirmation modal step. I will copy and paste a couple more blocks of code here. We're going to import a React hook that we've made called use confirm address. And the way that this will work is like so. You pass in, you initialize the hook inside your React function. You pass in an access token, and it's going to yield two objects. One of them is a ref object, which we can pass into our HTML form ref prop. And then show confirm is the function that we can actually call whenever we want to display this confirmation modal to the user. In this case, I'm going to put it inside of our form submission callback. So I'm going to create a statement here that awaits a response from this confirmation modal. And if the response's type is equal to no change, meaning the user declines to use this updated address, then we'll go ahead and submit. So let's just look at what that looks like here. And I do have to pass in another dependency to our callback. So now if let's say I'm searching for an address, but I decide not to select one of these options, I'm typing it in manually. So I'm going to type in an address that I know is not actually real. And so when I click confirm, you can see that we're now prompting the user to double check and see if they actually typed in an address that they know is correct, or maybe they made a typo. In this case, we're saying this is actually the closest address that is real that we think you meant. Is this what you meant? So as a user, I can say, oh yeah, I made a mistake. Or I can say, no, the address that I provided is the one that I wanted to use. So you can say no. But if I do accept this, then it'll go ahead and autofill the form for me, and you can continue as usual. And again, there's a lot of ways you configure that. You can configure under what conditions that modal will pop up to allow users to confirm their address is correct. But this is sort of the most basic implementation. So with that, I think that mostly wraps up what I wanted to show, but happy to answer any questions that anyone has.
Okay, thanks, Robert and Mark. And yeah, I guess, Mark, if you can, yeah, I was going to ask you to stop sharing screen. Yeah, so to those that are watching, are there any other final questions? We'll hang out for another couple minutes while you collect those. If not, well, I don't know. So thank you for sharing that one, Mark. That was like, you just blew my mind with the like pseudo slippy map that's actually made out of a static images API call. So that's pretty wild. How can you tell, I guess maybe share more about like Search.js hasn't been out as long. Like Mapbox Geocoder goes way back many years, and Search.js is pretty new. How's it been received? I mean, is it getting a lot of usage?
Yeah, I mean, we primarily launched it when we started our autofill product. I'd say that was the kind of main impetus for us. But we are investing a lot of time into positioning it as something that eventually we hope will be able to provide SDKs for our geocoding API and other APIs. And I will just tease that like there are going to be some really cool new improvements to Search.js coming in the coming weeks. So please stay tuned, and we're really excited to be able to add some really great new functionality into it.
Awesome. Okay, well, thanks. So I'm not seeing any more questions. So I think with that, we can wrap it up. But thank you both for coming and sharing this, very critical part of building location-based applications or critical supporting function to any map. So for those of you out there who are building with Mapbox, hope this was helpful to you and that you can start adding geocoding one way or the other, whether you're using React or vanilla JavaScript. But yeah, thanks for your time, and we'll see you at the next Getting Started webinar.
Thanks, everyone.
Thank you.
Take care.